Start doing that. A little bit about myself. I'm a penetration tester. I primarily test web apps, and I've been doing that for about the last 4 years. I also teach the web app pen testing course for SANS at the mentor level. I blog, I tweet, I write a lot of code, so feel free to connect with me and meet up. All right, so as I mentioned, attacking authentication web apps. So it's a really wide topic. So I'm going to touch on all of these things and occasionally on some defense, but mostly it's going to be an offensive talk. But I will throw in some nuggets, so if you're a developer or maybe like just you own the system or something like that, give you an idea of certain risks where these things are at. The reason I like always attacking authentication is because it's ubiquitous in everything. Every modern app has some sort of piece, and it's usually a username password type thing where you enter it and then you have some sort of privileges. Historically, users are bad at choosing passwords. Not everybody, but really you just need one user out of the several thousand that might live on the system to gain access to it. Scanners. So a lot of people, they are scan and forget type things. They scan it, they say it's secure. Scanners really do a bad job at testing anything authentication. They might be good at cross-site scripting and SQL injection, any sort of those other flaws, but authentication they're bad because most web apps are made differently, so it doesn't do a good job. Audits don't accurately measure risk. Basically, if you've ever done like an audit or a pen test of something that's in a non-production environment, user accounts aren't real. So it's just a bunch of dummy accounts on there, so rarely does an auditor or even tester go into like doing passwords attacks against anything. So the methodology I'm going to use, at least for this talk, is just some basic recon scanning, then enumerating users, testing the account lockout and trying to bypass it, different password attacks, and then I'll explore some other authentication authorization flaws that are really unique among web apps. So for recon, it's a big topic. I'm only going to touch on subdomain enumeration and port scanning that is very web specific. And the only reason I'm even doing this is because ideally, if you had authorization to test, example.com, you have this big scope. You're going to want to find as many subdomains as possible of example.com, or you're going to want to find as many places that you can attack this certain login. Authentication doesn't always live on 80 and 443 as far as the ports go, so you want to be able to check lots of different places. So there's several ways to enumerate subdomains. The easiest one is being a zone transfer, which your a DNS zone record or a zone file just has a list of records where the IP addresses correspond to the host name. So if you can get a hold of that zone file, you can basically have all of their subdomains. Other ways to do it is just search engine reconnaissance. So Google Docs, basically you do site:example.com, and then all of the search results that for example.com will show up, like mail.example.com and so on. And then there's various tools that do this sort of stuff for you. So, for an example of a zone transfer, you would just go to whois.net and you'd look up your target, and then you'd see the name servers in the bottom, and that's who you're going to try to transfer that zone record from. So, this particular one had it set up correctly where I'm using NS lookup here to try to transfer to do a zone transfer to my own computer. And zone transfers are typically only allowed between two DNS servers, which makes sense. You don't want anybody to get the zone file. So this one's configured correctly. A canonical example for one that is not configured correctly lets me do a zone transfer. So you can see the commands for NS lookup, and then it goes through and it shows the different subdomains for this particular contrived server. I mentioned that there's other places or other ways to find subdomains. Different internet sites like crt.sh and DNS Dumpster, they do internet research, and so they're constantly scanning the internet and finding out subdomains and recording things, and they offer basically free resources for anybody to look up a domain and see a whole bunch of subdomains. VirusTotal has it just because you're looking up threats from a particular domain, you want to see the subdomains that it's there. There's Google Docs, like I said, the site directives for it, and then you can also do brute forcing subdomains, which is essentially taking a word list and running it against your target, and whatever resolves, obviously that means the particular subdomain. There's tools that do all of this stuff for you. Probably the most complete would be DNS Recon. It does, I think, all of those things that's in the list, including attempting zone transfers. It's in Metasploit. Sublister is also popular. I wrote one, does find subdomains, which this is sort of the output for it, and you can see that at the top part, it's basically querying those resources, crt.sh and DNS Dumpster, and putting a list of subdomains together that you can go ahead and try to do. So lots of resources for finding subdomains, but the whole goal is to just get a wide breadth of login locations so you can try to test the authentication. So once you do have a wide range of subdomains that you can go ahead and test, you're going to want to look for open ports that indicate just web services. Sure, you want to scan them for all of the other things, your FTP and Telnet and all of those type things, but what I'm focusing on is purely the web ports. And if you ever use something like Nmap, the default scan is just 1,000 of the most common ports. And the 1,000 most common ports, though, doesn't actually cover all of the web ports. So you're either going to want to kind of get a custom list of ports you want your scanner to scan that is dealing with web stuff, or I wrote a couple of tools to do that for you that will just scan whatever you tell it to. Whatever URL you go to, it'll scan it. So that's the Sidekick and Get Website Info. One's Python, one's PowerShell. It basically just helps prioritize the sites because it goes out to all these different URLs. It'll record the title, the website, as well as the server type. And the reason this ends up being important is because if you have a really, really wide scope and you scan a whole network, you'll get a lot of garbage for web ports. You'll get like 1,000 printers or something like that. And so you want to have the title of the printer so you can just immediately eliminate it from your list and not have to waste your time by browsing to it. So to generate a list of URLs for web ports, there's another tool that I wrote. It just simply takes a domain name and appends a ton of different web ports that I've sort of come up with, either through reading up on things, or Nmap has specific ones that it identifies as HTTP or HTTPS. And this is the output of one of the tools. Just give you an idea. It gives you the title of the site and the URL and the server and the redirect URL. So anything like that can keep you organized and eliminate the stuff that's unnecessary, while at the same time, if it gives you a title to some popular open source content management system or something like that, you can kind of take the steps to do further enumeration on it. If you identify it as being old or an old version of something, there might be a public exploit or something available. And that's why we do this. It's if you find some commercial product, a lot of times if it's on a non-standard port, it might have been set up for some development purposes or some test things. So you want to try default passwords. And if you get in there, that's great. Maybe there'll be data on it, maybe not. Maybe there's something that you can use to go further. As I said, it might be vulnerable to known exploits where you can sort of do the easy job and look at Metasploit and say, yep, it's vulnerable to something. And just in the end, it provides more targets, which provides more opportunities to do all the things that we're going to learn about now. So, onto enumerating users. This shouldn't be so crazy at first. You guys, this should all be basic common sense type stuff. But if you own an application or if you're a developer, there's hidden risks that go along with all of these features of an application that makes it more user friendly or increases the user experience. So first thing you look for in visual changes, and the whole goal for user enumeration is to gather a list of users where I do not know things. So at Microsoft, I take an invalid user, so not a real account, and Microsoft will tell me that the account doesn't exist, right? So that makes sense. And with a real account, it'll prompt me for a password. So wow, now I know a username. That's great. So in theory, if you have an application that just tells you like this, you can just get a really large list of usernames and bust through it and record the ones that give you a password prompt. So then there's applications that, in fact, a lot of applications these days are designed not to tell you the username or the password. It's which one. So it's letting me know that the username or password did not match. All right. And even for an invalid user, so this is a valid user, this is an invalid user. It's the same error message. If you were to measure the length of the HTTP response, it would be the same length too. But under the hood, so this is once again a valid user, under the hood, this is what it ended up looking like. So there was a little XML part where it showed me a login status, and for this one it was -2. But for the other one, for the not a real user, it had a -1 login status. So all things were equal as far as the error message displayed, but this sort of thing let me know that a user was valid or not valid. And for tools and stuff like that, Burp Suite and Zap both have a comparison feature where you can take the HTTP responses and see what's different. So in this case, I had mentioned that the response lengths are the same, and so just looking at the response length alone would not tell you any differences. All right, so this is a timing-based thing. So on the right is just a little timer. On the left is me trying to log in with not a real account. It actually took 10 seconds to respond. This side of it took a particularly long time. It's more common where you see that it's just maybe a second versus a half second. And so what you would typically do to account for latency is just kind of bust through a bunch of accounts really quick, and the ones that are consistently returning at a different time, that's the ones that either are valid or invalid, whatever you think. And this, in this particular one, it only took 1 second for a valid username to get checked. All right, so then there's the sort of features. Even this part is secure, right? Like it says username and password do not match, so it doesn't tell me which one's which. This is for an invalid account, but a valid account, it would give me the same error message. It would just tell me username and password do not match. So it's designed to be secure and not give up any users. Unfortunately, the forgot password link doesn't do that. So not real account, it tells you can't find a user. You get a real account, it gives you, the prompt for the password reset. So they built the front end to be secure and not give up any information, probably because they had some sort of audit finding for it eventually, but then you have this feature that's just there. It's a feature. I mean, I don't think you can design a password or a security questions things to do anything else otherwise. Like it's going to have to tell you the user's there. So this is one of those usability features that, like, listen, it's the risk right there. And I mentioned there's different ways to generate usernames if you don't know what you're going to do. So there's like tools on GitHub. There's tools in Burp. You can just code something yourself where you do first name dot last name from your Outlook or something like that. There's ones that like take the census data so you can figure out the most common names. The ones that have been most effective for me though is either metadata or just calling the help desk and asking. So for metadata, you just look for a file like you do your Google search operator and you do file type PDF for example.com. And so when you pull down the PDF or the Word document's probably better, you can pull metadata from it and it'll tell you like the username that created that file. And so that sort of gives you an idea of what the naming convention might be so you can plan your attack. Yeah, but calling the help desk and asking has been the best. All right, so the defense is just that a generic error message as you've seen, letting you know your user account or password is incorrect. And for a forgot password message, I mean, if you're doing security questions, I think you're kind of stuck the way it is. But if you're not, it's one of those send an email regardless or show you that an email might have been sent if you are a valid user. Just something that doesn't give things away. All right, so other built-in enumeration features, menus, APIs, and just generic commands that might be run. For menus, if you have access to an application, a lot of times once you have access, there's a whole, they just give away the rest of the users, all of the usernames and even their roles too. So like this is hip chat, it's sort of like a Slack, if you're there, you can tell whoever's on it. And that's usually because they're using some sort of APIs, whenever you press buttons, it makes a web request and gets a bunch of users and filters them and queries them. And so if you see any sort of APIs, you want to go ahead and test them. A lot of APIs don't require authentication if it's just something like enumerating users. So that's sort of one thing that you would look for. So yeah, the rule of thumb is basically, you want to know your own application, and if you have one of these applications, just know that it gives up all your users and things like that. It's not necessarily the biggest deal in the world, but it's a risk to know about. And testing your logins. So you've seen some of the use cases with invalid usernames and valid passwords and so on and so forth. If you own one of these things, you're a developer, just check them to see what they give up. All right, so done with enumerating users, onto testing account lockout. So if you have a bunch of usernames at this point, we want to try to start guessing passwords, but first, determining the lockout policy is kind of big. Most applications have an account lockout policy, and if you're a tester or something like that, you don't want to lock out a bunch of normal accounts. So it's one of those things that you need to know. But once you do figure out the lockout policy, we can begin testing a little bit further. So once again, the easiest way that I think to figure out the account lockout policy is call the help desk if there's a help desk number and just ask them how many times, because they're there to help and they'll probably just tell you. But otherwise, you can research the framework. If you have some sort of well-known framework, you can sort of look it up, hope there's a default setting and hope that's the right one. You do have some applications that'll tell you, like as soon as you fail a login once, it'll say you have 5 attempts remaining before we lock your account. And then sort of the last case is you just keep trying until it either gives you some indication that you're locked out or not. So to start bypassing stuff, when you log into things, one of the first things I do is I look for client-side counters. So the way you can imagine a lockout works as far as code is concerned is, when this username fails a login, increment the failed login counter, and when the failed login counter is greater than 3, lock out the user or something like that. So that's supposed to be done on the server side. Clients shouldn't be able to affect that at all, but in some cases, they will put a counter on the client side. And so, this is my first attempt at logging in. If you guys aren't familiar with HTTP, this is just a post request. So this is what your browser is doing in the hood or under the hood when you're trying to log into something. So, a post sort of means the body of the request where all of my credentials are going to be in the body where other people won't be able to see it. But That's what this is. So I failed to log in, and then when I tried to log in again, my counter was already incremented to 2. So it kind of gave me an idea that maybe this C equals 2 is actually a counter. So to bypass it, I just set the C to equal 1 the entire time, and I was able to continually try to guess passwords against these users. So the other thing, I mentioned that that counter is typically associated with the username, and it's associated server-side in the database. Other times, they will actually give you a cookie first when you first go to the site. They'll give you a cookie, and then they'll associate the counter with that particular cookie. The idea is once you get a new, if you do log in successfully, they give you a new cookie, so it doesn't matter. But in this case, sometimes trying to just delete your cookies will let you bypass the account lockout altogether. The other thing that you can do is try using basic authentication. So if you don't know what basic authentication is, you'll see it a lot if you go to a website when you get the initial pop-up where it says authorization required, and you put in your username, password. Underneath the hood, you're actually, this is a regular authentication, and this is basic authentication, but the important part is the response here. So when I try to log in normally, I get this 302, which is they're redirecting me back to login. It's sort of an indication that I failed to log in on this one. But if I'm using basic authentication, I get unauthorized. And the reason it's doing that is because it's actually interpreting these credentials. So like I was mentioning with basic authentication, all it is it's your username and your password with colon delimited with that's base64 encoded. And it goes with every request. Your browser stores this as the authorization header, and it goes on every subsequent request to whatever domain. So when I got this 401 here, as opposed to on the previous slide where it was a 302, what I know then is that my credentials are being interpreted. So that it's processing them in some way. And when something like this happens, it's sort of like an unexpected authentication. Like they don't expect you to be using basic authentication, but they do allow for it. So in this way, several times I've been able to bypass the account lockout because they don't have any counter set up for basic auth. All right, and sort of a kind of a cool bug is, so this is a commercial identity management product, and it's set up in such a way that even when you lock yourself out, you get username and password do not match. So it stays true the entire time of not letting you know the username. It doesn't let you know you're locked out at all. I could guess 1,000 passwords, and as long as I'm failing those attempts, it's just going to give me the same message. But the bug was, once you get the password right, if you're locked out, it gives you this. So it gives you an error letting you know that you're locked out, which, I'm sure somebody had to find that before, but they're like, okay, well, you're locked out, you're good, But, when you think about it, is if it's giving you a completely different error when you got the wrong password the entire time, and then when you get this, it's correct, that means you know the password now. And since this was an identity management site, it was a single sign-on site, so this is where they set the passwords, and then all of, this was the single sign-on password. So once I knew their password here, I knew their password everywhere. And on top of that, I could just call the help desk and I said, hey, I'm this person and I locked my account. You don't have to reset my password. I know my password, just unlock my account. And that worked. So there's that, or if it would have automatically unlocked, this one wouldn't have, but you can just wait for it to unlock itself. So if you find that bug, it's pretty cool. All right, so then other places that evaluate credentials. So basically, these are places that usually you have to have access to the application, so this is kind of a place to brute force somebody else's password and bypassing that lockout. And the way you end up doing that is you look for places where you're using the password again. And the most common ones, I kind of mentioned account creation when you set a password for the first time. A lot of times it checks whether or not a password already exists for some reason. Password resets, they always check whether when you're resetting your password, you have to put in your old password. And that's the case on this one. So in this application, it had an update password spot. I could go to it, and as soon as I entered the old password and I clicked down on the box, it triggered some JavaScript and made an AJAX request. So it's making an HTTP request in the background with my old password to verify whether or not the old password is correct. So it's doing this, and the request, it was a really poorly designed app, so the request was actually a GET request. So it's bad to have any sort of credentials in a GET request, but this was the URL that I could go to see what was going on behind the scenes. And so it was verify password, and the Q was my old password, which in this case is bad pass, and it has my user ID next to it. And so if I put in a bad password there, an incorrect password, it returns back password entered does not match current password, and that's the error message that would show up on the other screen, if I were doing this correctly. So a blank response, though, indicates success, like I got the correct password. So anybody could go to this page, though, and just cycle through user IDs and guess passwords, and this one didn't have a lockout associated with it. So while the website, 3 invalid logins would lock you out, for this check password spot, did not. All right, so that covers the testing account lockout. So now on to the password attacks. All right, so 4 different types I'm going to talk about. A lot of these may not be new to you, but some of them might. So for continuous guessing attack, a lot of people would call it brute force. An actual brute force would take a really long time. That's something you can do when you're cracking hashes but not guessing passwords over HTTP because it takes a long time. So it's typically just a dictionary attack. You have a hybrid. You have a dictionary that has numbers and letters, and whatever the password policy of the organization is, you throw on things. The downside of this is if you haven't bypassed account lockout, you're going to lock something out if you try a dictionary worth of passwords against somebody. So a lot of people use what's called password spraying, which is where they take a large list of users and they try a very small amount of passwords, typically under the threshold of whatever the account lockout policy is. And this ends up being really effective, and because you're not really worried about testing the super difficult passwords, you're testing easy stuff, like month, year, August 2017, exclamation point, where it meets everything, but it still meets the all of the password requirements. And then, keyboard walks for the people who think they're clever. Those are great too, just kind of up and down the keyboard, whatever meets the requirement, but still there. Those like the keyboard walk ones are really great because it ends up being like important people, like system administrators or security personnel or something like that, because they just get jaded and bored and they walk up and down the keyboard. So those are my favorite. But the data I have on this is, around every 2,000 accounts guessed or usernames guessed, I end up getting access to something. All right, so the defense to this obviously is MFA. That's sort of like the whole talk. The defense is MFA. If you use MFA, most of this stuff you won't have a problem with. A CAPTCHA, so rate limiting all of the requests. Nobody's going to want to go through and guess passwords by hand. And the blah blah blah, educating users. All right, so logging though. So I mentioned logging, and this is the important part. So for logging, I've worked with a couple SOCs when I'm guessing passwords, and I say, hey, all right, I'm guessing passwords. Can you see me? And they say no. And I say, okay, well, don't you notice a big spike in requests for authentication? They're like, yeah, but what they were doing like almost every time is, this is a normal architecture, I'd say. People connect over the internet and then it gets load balanced into your applications. The problem is, they were querying these web server logs, but all of the requests looks like it's coming from the load balancer. So if you don't have a pass-through on your load balancer that's taking the actual client IP addresses, it's not going to do you any good because otherwise you'll do something stupid and like blacklist your load balancer and then you won't have any traffic at all. So always just make sure that you're actually getting the true source of your client IPs. Otherwise you won't be able to stop anybody. And yes, there's always the defense that they can just move to another IP address, and that's true, but slow them down a little bit. All right, so this one you may not have heard of. I call it indirect password guessing. It's what happens when you get an error message like this. We've seen all the previous ones where it says, incorrect username or password or incorrect username or whatever, but this one just says, actually, I'm sorry, this one is invalid. This is what it says normally, but this is the weird one. Okay, no, that's the weird one. All right, you do not have the necessary permissions. So all the other use cases, same sort of error. And then all of a sudden I get this weird error. It doesn't let me into the application, but it says I do not have the necessary permissions. So trying to figure out what that means. All right, so then you got to kind of think about how web application architecture is, and I know this is kind of poor, but you might have a web app that is drawing from some sort of LDAP database, maybe as a primary or a secondary, but it does have some sort of LDAP that it might be tied to. And this usually isn't the organization's like real LDAP. This is like a replication of their LDAP. And the whole idea is like you don't want anybody to be able to just like hit your Outlook web app portal and lock out everybody's accounts, right? So it's just replicated usernames and roles and stuff like that, not the actual one. But the fact still remains that you have like everybody's credentials are with an LDAP, and you got to think like, all right, maybe there's let's say this web app is GitHub, and there's a GitHub group on your LDAP, and only people who can access GitHub, they have to be a part of the group. So indirect password guessing happens when, let's say, I don't have access to GitHub, but you correctly guess my username and password on that GitHub site. It still looks me up in LDAP. It still says, yep, those are valid credentials, but then it looks at my role. I don't have GitHub, so it gives me this, you do not have the necessary permissions. So if I'm trying to attack GitHub, this isn't very useful. because I can't access it. But what it is useful is now I have these network credentials. And if you can find lots of sites like this that are associated with the network, like the same reason you do all the subdomain enumeration, is if you can find error messages like these, you can attack some arbitrary site and apparently look like you're not getting in, and then once you figure out the credentials, you just go to the site you want. So you're indirectly doing it. So there's a long technical explanation of what I just said, or kind of thrown out there. But this does happen. So GitHub was a good example because it was a flaw for them. So for not a real username and password, I get invalid LDAP credentials. Even when I use a valid username and invalid password, I still get invalid LDAP login credentials. But when I do find a match and they just don't have access to the GitHub group, I get this weird random message. So that kind of gave me an idea that that was there, and that I was able to use these credentials at other places. So this is the same thing, but with timing. I think it was a video, but I'll probably it's a long video. GitHub fixed this, and they got rid of the error, but it still actually there was still a 10-second delay, so it was just timing-based enumeration, but it's really just that. It's just me logging in, and it takes 10 seconds. So defenses against this, it's just really going through all of your web forms and seeing how they respond to the different types of input. Invalid username, valid password, so on and so forth. And for this one, even those who are not in the same group. All right, then the last password attack is MFA half-guessing. So if your application does have MFA, make sure you have it everywhere, because the idea is some applications only prompt you for the second factor once you get the first factor correct. So like for Microsoft, if you get the password wrong, it tells you the password's wrong. If you get the password right, it says approve sign-in request. So that it prompts you for the second factor. So at this point, I know the person's password because it's prompting me for the second factor. And if you don't use MFA everywhere, then I can just go to wherever you use that initial password and try it. So always prompt for a second factor. All right, so now these are the cooler one-off ones. So these are complete authentication or authorization bypasses. So I'll give you 3 different stories where it happens. There's no great framework for finding these type of things because all web apps are different. So I got 3 examples. I got one that, authentication and authorization bypass via host header manipulation. I got one that's a portal protected app, and I'll go into what a portal app is. And then I have a glued application, which is taking an open source project and merging it with some COTS product for whatever reason. All right, so the first one. This is sort of the summary of how things went down. I don't have access to the web application. I did my Google dorking, I did my search enumeration, and I found a few different login paths. I found the /login, and I also found a /welcome for this example site. When I went to the login page, I could see that the host header was echoed within the application. And then changing the host header basically gave me full access to the app. And so here's the way it went down. So I went to the site, I went to the login screen. You can see the arrow where it says the host name was here. For those who don't know what a host header is, when you make an HTTP request, when the browser does it, it's just a required header, and it's typically the domain name of the system. So if I go out to login at example.com, my GET request would go to /login, and my host would be example.com. So that's the case here. So the host name was there, and it's kind of strange to just have it randomly show up there. So this is just sort of, I mentioned earlier that I found another path. So I found login and I found welcome. So sometimes in applications you get really lucky and you can just skip the login page and go straight to the welcome page and it'll just work. This wasn't one of those cases, so I made the request out there and it gives me a 302 response, so it redirects me back to login. So no work there. So I decided I would change the host header. So I changed the host header, and this is a screenshot of burp. So I'm doing request modification. So each time I make a request, it's going to add the host 127.0.0.1. It did get echoed like it was supposed to. And when I tried making this request, though, it still sent me back to the login page, so that didn't work. So next, I tried localhost. And when I went to welcome this time, the response you'll notice was a 200. So it actually let me go to that page instead of redirecting me back to login. And when I went there, I know there's a lot of red, but it gives me this administrative links section, and it makes me the web administrator. So if you notice at the top, you see it says local machine. So this was some sort of lazy developer shortcut that if you're on the local machine, then you must be the developer, and therefore you can have full access to the app. All right, so obviously the takeaways is don't do that. But if you're a tester, testing the host header, see how it responds to different input, just a good thing to do. All right, so the portal application. So a portal app is like, when you start with a new company, they give you access to some web portal where your credentials work, but within there you don't have access to anything. You might have access to like your timesheet or something like that, but you don't have access to like accounting or HR or whatever other systems might be in there. So it's just like you have access to the app, but you're not a part of any groups. And so that's what this case was. So I was able to actually directly browse to the portal application that I wanted to go to because I did some search engine enumeration. I found there were other links in there that I didn't have access to, but I could browse directly to them. But when I went there, it just told me everything was unauthorized. So whenever you go to a page, JavaScript typically loads, and sometimes JavaScript gives away different URL paths that exist. So I read the JavaScript, and I navigated to a few different pages. Couldn't do anything. I read more JavaScript, and eventually I had access to the app. So here's how it went down. So once again, this is the IBM Portal. I don't know if it has a special name, but I'm within the IBM Portal. If I had access to applications, I'd have all these little buttons that would show up. Like I said, I could directly browse to a particular application that I found via search engine. So I went to this application/login, and it tells me I'm unable to do anything because I don't have a contractor ID. So bummer, I read some JavaScript, and I went ahead and went to a different page. So I went from /login to /welcome, and it logged me in. So now it says welcome me. It says a bunch of other stuff. But yeah, it let me in, so that's really cool. But unfortunately, I tried clicking on a few links. There was like some search links and browse links within this page, and I couldn't do anything still. So each button I clicked, it just gave me back to that same ugly error message. So I read more JavaScript, and I eventually came to this page. And this page let me do things. So it was actually let me look up individuals and first and last names and got a whole bunch of PII out of it. So, this was a self-register portal. So anybody on the internet could register for this particular portal, didn't have any access, but you could eventually get there. So big exposure. All right, so don't rely on the portal itself for authentication, especially if you open it for everybody. Know that there's a possibility that somebody can directly browse to things and that things could be implemented incorrectly. Like in the case of this app, they relied on the portal. So like I had authenticated the portal, so that meant I could just go to this other application and it just read that cookie and kind of logged me in. And then it didn't make sure it protected all of its URLs requiring the logins. All right, so this last one, I call it the glued application because it had an open source, it was an open source content management system, and this company, they had to put on a semantic authentication piece because, like auditors require you to have all of those password requirements, lockout requirements, all that stuff. And this open source content management system didn't have that, so they stuck this semantic thing on the front end. I didn't know that at first, but there was a cookie that came with this that kind of gave me an idea that it was using an open source framework. And if you see something like that, you want to download the framework and take note of all the things that you can do. So I took note of the login location, and I tried to just manually browse to that login location, thinking maybe the semantic thing's there, but I can just browse to the other part. Eventually, I was able to modify the request method. So I've talked about gets and I've talked about post. And I was brought to actually at that login page that I saw, and at that point I could just log in as any user without the knowledge of the password. So here's the HTTP request response pair. I'm going to this site with the slash is just the root directory, and it automatically will redirect me to semanticauth.example.com, and it sets this cookie, and this cookie let me know that it was an open source framework. It's ELGG. I can't actually remember what the framework was, but ELGG, if you look it up, you'll find out it's an open source framework. So it gave me this semantic auth screen, and this had all the bells and whistles of a secure thing. You had to have long passwords and complicated, and it locked you out. All right, so once again, when I downloaded that framework, I saw that when I logged in locally to my application that I downloaded, I go to /login. So I'm like, all right, let me just try to go there. So I went there. Unfortunately, it still sent me back to that semantic auth page. And at this point, I kind of thought, like, how did a developer write this piece? Like, did they say that anytime somebody goes to this resource, it's going to redirect them? And I'm saying, okay, well, maybe they did it in such a way that anytime that it was a GET request, you wouldn't get them. Because when you're browsing to a site, it's always GET. You don't do a post, you don't do anything else. So it turns out I can make anything other than GET. And when I went to the login, it didn't redirect me. It actually sent me where I was supposed to go. So it gave me this login screen. And at this point, at first I tried a few a few like random usernames and stuff like that. And I'm like, all right, cool. I can bypass account lockout here because things weren't working. But once I tried a valid username, it just let me in. So it let me in as the administrative user. I just had to, as long as I knew a good username, in this case, I blocked it out. But yeah, it just let me in as the administrator. And the way the web app was actually set up was once it authorized you from that semantic spot, it made a call to that login page that I was just on with just the username. So it basically authenticated you in semantic, and then it authorized you on that username spot there. So it turns out all that spot needed was a username, and once you get in, so gain administrative access to the application just by doing nothing. So once again, public app, and go from zero to admin. So takeaways for all this, or for the glued application at least, is you look for components that are part of the known framework, download it, and try to do your best, and think, how could somebody screw it up? All right, so that is the talk. I've covered all of that stuff, from recon to user enumeration to everything in between. Questions? Anybody? All right, thanks.